Hello, everyone, and welcome to the second session of Lexmark webinar series. I am Nina from Inspire. And if in case you have missed the last weekend webinar, my colleague Marina will now post the link to the previous session into the chat box. However, you can also scan the QR code that you can see on the slide, and there you will find the links to the upcoming webinars as well. And in today's session, we have Lexmark Senior Enterprise Architect Mark DeBeaumont, who will talk about system architecture and design, cloud architecture, and how all of this interconnect in an enterprise architect daily life. But again, before we get started, I would just like to do some basic housekeeping to help run this webinar as smooth as possible. So to start with, the presentation will take about 35 minutes, and then will be followed by a 5-minute Q&A session. If you guys have any question, please don't shy away from the Q&A box, which is just at the bottom of the screen. And of course, we will try to get through everyone's question. But if again, we run out of time, we will definitely respond to your question via mail. And without further ado, Mark, the stage is yours.
Thank you, Nina. So good day, everyone. My name is Mark DeBeaumont. I've been in enterprise architecture for over 20 years. The last 10 of those have been with the Lexmark enterprise architecture team. The last couple of years, I've actually been working with the transformation services team, helping them document and organize the transformation service products. It's our new offering that we're coming out as part of our digital asset. During my tenure as an architect, I've worked with several tools, ERAS, Oracle, PPA, System Architect, and others. And they all require a lot of maintenance. I'm sure many of you know that, updates by architects on a continuous basis, and without a rigorous governance program, they're hard to maintain. For the last 2 years, we've been actually leveraging UPMX and Designer, and some of the advantages we've found has been the integration with our Services Now instance. This integration has, for the first time in my experience, been allowed us to take our logical models and our logical solution development designs and actually then connect them to true physical components from discovery, whether those be in cloud instances or actual physical components on premise. And this gives us much more of a true picture of the enterprise, and it also keeps the constraints of what our logical designs actually connect to so that they are current and correct. So what I'm going to do today is just kind of go over a couple of topics. One will be how we use Inspire to actually develop solution architectures in general, the foundation for the architecture elements, how we've actually built out our continuum in Inspire. As we develop architectures, we've created some templates for our workshops so that we make sure we get all the components necessary to actually build a solution. And then what products we developed after we've come up with a solution to actually show the story. So which types of designs, diagrams are necessary for us to maintain going forward once the solution is built. So the first part is I wanted to kind of show how we view our primary architecture disciplines and how that connects to the Inspire meta model. So if you look at an enterprise architecture, which is usually what we build, we leverage most of the Inspire components for strategy and for organization structure, the value process, and so forth, to give us that holistic view of the enterprise. The solution architecture is really kind of delve into a much more detailed version of that. We assume that the strategy and so forth has been established, and we connect that to our solution. And we make sure that we're building a solution within the strategy and objective contents for the organization. This can be either a business-focused solution diagram, or it could be a customer-focused solution diagram, depending on who the audience is, of course. And then we get into some system architecture diagrams. Most of those are still at a high level in Inspire because we're trying to just simply show much more of a logical constraint. But we do talk about what are the data stores, what are the components necessary to build out a solution, what services are involved, and those kinds of things. And I'll kind of go through those as well. So the architecture continuum is really our overall library of components that we've built from an enterprise perspective to help any architect, whether you're a process architect, data architect, solution architect, whatever, to come in and start with something. So we have templates in those areas, and we have framework components specific to those particular areas as well. We leverage the open group methodology and framework for our primary architecture structure. And we have found, we've played with multiple, but we have found that this particular framework is probably one of the easier ones for everyone to follow. It has a lot of latitude, allows you to pick up and change your mode or method whenever you need to. We also have defined particular nomenclature and standard notations for architecture. So when you're talking about a process or a data system or even software, if you're talking about that at a level 2 or level 3, you make sure that if you punch out and talk about data, that we're still talking about a level 3. So we don't have terminology issues, or we don't have differences in viewpoints as well. And then from a standards perspective, we've leveraged PCF for our processes. This is an APPC framework. Most people are familiar with that. We do leverage the FIA architecture components as well, because they are very standard, and we do a lot of work with the government as well. We also have the value reference model, which is kind of a high-level model that we use as primarily our building blocks for a lot of our components. And then we have certain areas for data, like our Microsoft Common Data Model that we try to use across our application platform. I'm going to punch out real quick and kind of show you that in much more detail. So this is our continuum. And as I mentioned, there are different components that we've put together in the library specific around the TOGAF framework. And so if we talk about building blocks, and this is the most common one, we can come in and we can look at the architecture building blocks that were built. I'm going to move these people down here. And this kind of gives us an idea of if we're doing in planning, if we're doing execution or governance, what kinds of blocks are available to us in this process. We can then go into one of those blocks. And now we have a process that is defined by all the other components that are necessary for this process to actually be something. So we have our business capabilities attached, and these capabilities are executed by this process. We have an organization attached. We have an application that actually is part of this process. Process runs in that application. We have data elements that are consumed by or created by or updated by this process. We also note the processes that are being consumed by these other ones in this context. A metric component. So if we wanted to measure how this process is doing or what this process is performing, these are the metrics that we can choose from. They've already been connected and established from a relationship perspective. And we can then, look at any one of these in much more detail if we wanted to find out something about this. So if I wanted to go into an information object and find out how this is applied at a level 4, this is the Microsoft Common Data Model that is associated to that one data element. So that data element, when you go to a level 4, has multiple elements from an entity perspective that we can leverage. This again. So now that we know we have a library or continuum of capabilities, what is the solution architecture process? And at Lexmark, we've tried to genericize this just to the point where it doesn't make any difference what kind of solution architect you are, what discipline you're focused on. These are the same basic functions that you would do regardless when you build a workshop. So at the top of the process is, what are the solution specific goals that we're going to be trying to achieve? What are the objectives? And we also need to define what are the key use cases that the solution will address. These have to be then aligned to, or at least constrained by, an enterprise level goal. So if we're trying to achieve something from a solution, it needs to further the corporate agenda from a goals and objectives perspective, as well as our own goals for the solution. Then we come down and we say, okay, who's going to own this solution, right? Who is responsible for the solution? Does it fit in the current corporate structure? If the solution is completely unique or something new that we don't have a structure for, what does the structure need to be? Do we just need to add some additional roles and actors? Do we need a new functional organization to apply this to? And we make note of all that as well. Then we move on to, what are the capabilities necessary for this to actually be a solution? From that perspective, what value streams are affected? What value stream will it actually function in or replace? What's the conceptual architecture? What are the primary components we need? So we start talking about it and pull together, what are the services that are necessary for this to be a solution? What are the applications currently available that we can leverage, which ones do we think we might need to bring in, what are the technologies, and so forth and so on. And then finally, we get into a point where we actually start building an actual logical solution architecture. So what is the solution going to be? How we actually look at each particular layer or diagram that we need to build out, and I'll talk about that a little bit later. And then we start taking that and pull together everything that we need for the solution. Once we've done that, we then take the generic continuum library objects and we make solution-specific objects, and I'll talk about that as well. So let me punch out again and show you this from a designer perspective. And just for FYI for everyone, I'm actually leveraging the presentation mode of Designer, which is the HTML rendering component, because it's much faster, and because we're doing these presentations, I don't want any issues with trying to load Designer or pressing something wrong. Anyway, so when we talk about the actual solution, we have templates for any part of our process in the architecture framework. And so when we talk about solutions and opportunities, there are templates that we can leverage that actually come together. And I'm going to show you the ones that we built for the Opera solution. And the first one, as we mentioned, are basically the strategy components. So if we're talking about trying to achieve something in one of our corporate goals, which is leveraging our MPS foundation, we then come up with specific solution goals, and then we come up with a strategy around that. Then we have some objectives, right? So we figure out what are our objectives that we're trying to achieve for the solution based on each one of these goals. What are the initiatives that we're going to be processing or we're going to address from that perspective? And then for each one of these objectives, what is the use case, right? So we can come in here, we can look at, here's a use case for achieving the analytics portal components and what are the data stores. And this is a general high level when we're talking about in the workshop, how do we do this? What do we need? We just start pulling this together, and this is the use case that we would actually leverage from that perspective. Go to the next one, which is, again, I'm going to try to go through these fairly quickly. I don't want to run out of time. So again, we look at, from a solutions organization perspective and roles and so forth. What are the areas that we're going to focus on for this solution? We're going to need an information services DA. We're going to need specific business area DAs for supply chain services. What do we have currently? Well, we have the organization structure already established. We don't have a gap in that. We have current roles that could be used, but then we have identified several roles that probably aren't existing that we're going to have to address. And we add that into the process. We come in and we look at our capabilities. What are the capabilities we want to leverage based on the initiatives? So keep a note of what are the goals that we're trying to do, what are the initiatives, try and put that together. And then we come up with what are the capabilities that we're going to try to leverage. So we are looking at impacting the data to analysis value stream that we have at an enterprise level. And in this value stream, we're going to impact the acquired data, the organized data, delivered data, et cetera, et cetera. And here are the actual capabilities that we're going to try to focus on. We then attach a technical capability as well, so that we're making sure that in order for this capability to function, we need to have this technical capability as well. And this capability will then allow us to connect actual technology and execution components to this overall concept. We then come into a much more abstract version of this. We use the TOGAF notation model for a lot of the high-level abstractions because we're in that framework. It's easy to use. But anyway, the intent is that we define some services that we need to build at the top. What is the streaming architecture that we're going to be talking about building? What is the transactional architecture that we're going to need to build? And what are any components that are currently out there that we could leverage for workflow automation, integration server, that kind of thing. And then we try to put this together at a high level as an abstraction point. What are those components? We then take this down to the next level, right? And this is still in that same discussion, but if we're talking about those, if we're talking about particular infrastructure of services, what are they? What do we need to address? And here's where we get into a lot of back and forth. We use a lot of Post-its and discuss how this is going to work between the two concepts of application technology and technology abstraction. The next level down would then be, what is the actual solution going to look like? And here's where we actually load everything that we need to build and put together a high-level diagram. And so we end up with all these components at different levels of abstraction that actually we can take each use case and we can run through those and determine what is actually being executed where, and do we get an output that we want. So some of the key architecture diagrams that are part of this building process. Flow diagrams, always, those at high level, we always come up with some kind of flow going from left to right or from top to bottom. What are the services that we need? Basically, what services are currently identified? What new services may be needed? Do we have a service that we need to build? Who's going to do the work at various stages, and who is responsible for the output? What does the infrastructure diagram look like? What are the technical needs for that? How does the solution deployed in the environment? What is the detail just above the physical deployment? Usually these diagrams then connect to CMDB elements that have been discovered as part of the actual deployed infrastructure. In some cases, and we don't do this a lot, but we've had to also put together some coding level diagrams. This is not that often. We try to keep everything out of the box or customized rather than build new applications as much as possible. But there are other scenarios where we need to build an application. It also helps us with the black box concept. So we can put a black box in our solution that actually is actually a large system itself that is actually being used. And it may have been previously defined by another solution architecture, or it may be something that is connected as a service that we're leveraging, or we may actually build it as a code application. And this helps us describe what are the inputs necessary and what are the outputs necessary for that development. So what I wanted to do next was kind of to show you how that works from an architecture perspective. And so, let me get rid of this bar. Okay. So when we first talk about the architecture, we talked about the different types of diagrams. And what we've done, rather than make independent diagrams, primarily just make layers. This allows us to put together the diagrams in the same venue, and we can build off each one. So we normally start with our reference architecture that we talked about in our workshops. What is the primary functions that we're trying to achieve? What are the key areas of execution that we're trying to address? And we come up with a high level, we think we need to have this, and we need to have another path, and we need to have this. And basically we take information from one side and we come up with some kind of result on the other side. We can then take this to the next level and we say, what is the abstraction model going to look like? And this allows us to look at what are the areas of execution that these people are going to deal with? What are the application services necessary for them to work in? What are the components necessary for those application services to function? And then we talk about the infrastructure services that we need, and what are the services that are necessary, or the components necessary for those services, and any other components that we talked about. And this is very similar to the template strategy discussion we had at the conceptual side. Okay. So in this particular one, we've taken the abstract model and we've just basically started adding components into it, right? So, what are the actual actors that we're going to be using? What are the capabilities assigned to this particular area and function? What is the process at a high level that we're going to leverage? And basically leveraging the process gives us that building block of the organization, the application, data, and any of the metrics that we need to assign. We then come into what are the application services. Based on that, what is the technical capability we need to leverage in order for that application service to function? Again, we add that into the mix. We talk about the components. So now instead of talking about a generic development portal, we actually talk about the actual components we're going to use in that development. Same thing for the warehouse and so forth. We talk about the infrastructure services, and if the infrastructure service requires a technical capability. This is, again, part of the standard framework that we have in our continuum. So this is something you can just simply pull over and use: data management, DET, web access, etc. We then talk about the actual components inside the actual solution. So what is the hot path, the warm path in our vernacular, but IoT reference? What are the components in the servicing layer? What are the components in the business integration layer, and so forth? And we have it, again, at a high level, all the services necessary for this to function. We then come in and look at what's the actual solution look like. So let me push this out a little bit. Okay. Our intent was to show that we have different components in our solution specific around those strategy objectives. So one's an analytic solution, one is a predictive solution, and one is an automate solution. Based on this, we can then talk about the components necessary to put together, so we can add a network. What are the network components that we need to have? Where are those layers, those boundaries? What are the peer connections? And then from a security perspective, what security elements we need to add as well. So we can do all that within this solution. So again, this is an architecture solution at a very high level that shows the complete process. And we can go back through in each one of those use cases that we saw at the very beginning. We can then go through and make sure that each one is satisfied with the correct output that we want. One of the things that we do from this architecture is we come in and we build out like the analyze portion of it, right? So we talked about the various components that would be necessary to achieve an objective. This is an analyze architecture. Here are the main components. We can then add the services on top of that. We can add the data flow. So what is the actual flow of data? The network components, and the security components. In this particular architecture, there is a black box that is part of our analytics component that we leverage. And we try to simplify the diagram, of course, by making it just basically a reference point, but we can go into that and actually show the diagram of that particular component as well. And so this is, again, the main components that are part of this architecture. What is the network components for that? What is the data flow between those components? What's the security that we've added onto this? And then we've also have connections to the physical instance. So if we wanted to look at the physical components that are associated, and I only added one because I didn't want to mess up the diagram that much, but we can go in and we can actually look at for this particular VM, which is a web server inside Azure. I can turn these off. We can identify that there is an instance running that's a virtual machine, and it has this connection. These are all connected through discovery. So these are in our CMDB. They're discovered on an ongoing basis, and this logical link between this logical component and these physical components is maintained by us. And so any of these we can then push out and click into and get the actual connection to the physical components that are available and running inside the CMDB. So the intent of this is to understand that when we talk about an overall solution, we're talking about going through the templates for that solution and then coming up with all the pieces and parts necessary to start putting together the Legos. And once we've gone through those templates and put together those Legos, we come up with this abstraction component. And then we can take each one of these parts and then delve into a much deeper version of that, so that we can get a picture of what's really necessary for any part of the actual solution diagram. We don't go to a significant layer below. but we do try to build out what makes sense from a logical component for each detailed diagram we need. So there's one for analytics and there's one for predict. Same components, similar data flows, similar services, but these are unique to that particular solution. So each use case that's specific to this would be able to be executed without the other components involved. Same thing with an automate type discussion, right? So we talk about this, and these components are all available to us. And this process allows us to then take all these components and say, okay, we're going to deploy an automate solution in one of our test environments, and we connect these logical components to those infrastructure components. And now we can validate that what we thought was going to be the data flow is in fact the data flow inside the physical instance. What we thought were the correct security components and the policies we thought we had to have, they actually are the right policies and the right security components. And we've had to make modifications to these diagrams, right? We thought we needed several NSGs. We found out we didn't because of the way it was structured. So we found out, the flow of data doesn't need to go from component to component. We can use a different method. So it does help us refine this as we actually deploy test instances, and we feed that back into the design element. Not to revise the design necessarily, but to make sure the design is still accurate and functioning, and to make sure that we're not doing something that doesn't go outside our primary concept of building those goals and objectives. So that really kind of puts together most of what I wanted to discuss. I mean, I think the key components is it really does require a foundation for the continuum. You need to have that library of components that you can leverage initially. In this type of diagram, you'll note that all the components are still the generic Azure components, Azure SQL, Azure Data Factory. But when you get into an actual solution in a much more detailed design, you'll see that we built actually unique elements, because these are actually deployed as part of that solution, and they're actually connected to physical components that would then be part of the actual production instance or test instance or QA instance, whatever you're trying to do. And that's really pretty much my presentation. I've covered a lot of things, but I wanted to make sure that everyone had a chance to ask any questions that they had.
All right, thank you for this interesting and insightful presentation, Mark. And now let's move on to the Q&A part of this session. I can see we already have a few questions in. So the first question is, how many solution architectures have you modeled?
So we've modeled dozens of solution architectures. We've used NSPI for several of our product areas in the last couple of years. The managed sprint services area, there's multiple solution architectures around that discipline. That's a service that we provided for many years, but we've remodeled it in NSPI. The Cloud One architecture, our Microsoft Cloud infrastructure, is modeled in NSPI as well. So it provides a lot of elements in the catalog that you can leverage in building a solution. And then based on those two, our transformation services product, which is a new product area for us, has all been modeled in NSPI. Everything from the abstraction and the objectives and the processes, the data elements, everything is in NSPI. We use NSPI again at a fairly high level. We talk about activities and so forth. We talk about data elements in the Microsoft Common Data Model. We talk about processes down to the activity level. But then we talk about anything much further down. We have specific tools that do that. So for like the ERD diagrams that are specific to attributes and stuff, we do different tools.
Right. And then the second question is, when it becomes necessary to update a diagram of flow for some reason, how do you indicate the plan of record is or versus what you're in the middle of tweaking? And also, how does revisioning work?
So we have a couple of things for that question. We have a governance board. So once a solution has been defined and accepted, revisions cannot be made without the governance board effectively saying, yes, those revisions are accepted. Architects can make multiple revisions on diagrams. Those are kept in NSPI keeps a revision. So those diagrams can be added onto as a revision 2, 3, or 4, or 5, but they are not accepted as a final diagram until the governance board does that. And there's a workflow inside InSpy that allows us to go from draft to straw man to confirmed, and then from architecture review board reviewed and accepted to architecture finalization.
Right. Moving on to the next one. How big is your solution architecture team?
So we have solution architects in all of our business areas for particular disciplines. So I can speak to transformation services, which is the product team that I'm currently working with. We have about a dozen solution architects, some focus on specific areas, but all work on the primary solution. So we have experts in the infrastructure side, we have experts on the data side, we have experts in the process side, but they all work together. So they have an overall knowledge of the entire solution and an overall knowledge of the particular product they're building. So they just rely on each other, and it's a very collaborative team. So that's probably true in all of our business functions. So when we talk about the management services group or the cloud group, those solution architectures also work very close together, even though they have expertise in certain areas.
Okay, another question. How do you keep the model up to date with the dev team? And if the CI versus CD pipeline, they are making code changes in infra or app layers?
So part of the concept of doing our black box scenario for that particular type of a question is really focused on the inputs and outputs, right? So when we have our dev teams working on new revisions or something, they have to go through that pseudo process of ensuring that the inputs and outputs remain the same. Or if there's supposed to be a change and we're supposed to have a different output, what that would look like. And then we can go back through in our other model and determine that output, how it impacts everything from the original solution and the components that we put in the physical instance already, all the way up to, does it still match the objectives and the strategy that we're leveraging for the corporation? So we do that due diligence. We let the code people obviously work and the dev team work independently, and they're building that, but they have those constraints of ensuring that the same inputs and outputs are achieved, or if we've already made a modification to either one of those, making sure that modification is updated throughout the entire process to ensure it still gets us to a value that we want.
All right, and the last question. What does it take to ramp up the solution architect, and how much training was involved?
So at Lexmark, we have different types of solution architects. Most of our architects have been either solution design people or SMEs in their own right for different areas, and they just have had opportunities to look at solutions in a broader context and been part of that team to do that. They then obviously get some background on how architecture components work together, how frameworks work and so forth, if they don't already have that. So we have homegrown quote type solution architects, and we actually like that because they're very much experienced in particular areas, and they've had a lot of background in particular solutions for the products that we're talking about as well. We also have solution architects that we bring in or we've allowed to certify in different areas. So we have Azure architects and we have AWS architects that are focused on those particular disciplines and have certified themselves as solution architects in those. That allows us to feel like we have architects that fully understand that particular product set and know how to use it. But we still go through a significant experience process with them to become an actual solution architect lead, if you would, or at least someone that we would probably provide, go ahead and build the solution and for this particular request, and let's put it together. So even though you may be certified in Azure or AWS, the experience of the product set is really what we hold as a primary function of a solution architect.
All right. So these were all the questions for today, and thank you for answering all of it, Mark.
Oh, you're welcome.
So thank you everyone for attending the session today. And as you can see on the screen, here are some links that might be interesting to you. You can visit our website, book a demo, or find the full webinar series landing page. And on this, I wish you guys to have a very nice day and hope to see you again in the upcoming session next week. Bye-bye.